Hi guys, this is section 2 of chapter 12, and today we're going to talk about measures of central tendency, measures of variation, and we're going to determine how to distinguish population versus sample. The two parts, the measure of central tendency and the variation, is going to be not very complicated because you're going to mostly be using the calculator. And so I'm going to explain the concept quickly. And I'm going to show you how to use a calculator because these things really won't make any sense unless you actually do it. So let's look at what are your options for measures of central tendency. So when we say central tendency, it means what would describe the middle of your data. So for example, sometimes I will calculate the average of the test that you guys took, right? It is to see how most of you did instead of just looking at individual scores. Obviously, there are some times that average doesn't mean much, especially if some of you did really, really well and some of you did really, really poor, then it would average to the middle, even though there is nobody who actually got the middle score, right? So there are different cases where you have to choose different central tendencies. So let's talk about mean, which is very well known to us. This is what we call average. So when we say mean of a data, it's an average, and you know how to find them. You add up all the scores and divide it by how many data set that you have. So let's look at the example. So this is your page, I don't know what page it is, 755. And then we're going to figure out central tendency, but especially average for all 4 questions. I am going to use a calculator, and I'm not going to use a calculator the way you might use it. So I want you to turn it on, and then go to Stat, and then Edit. And if you have something on L1, do Clear, Enter. And then L1 gets cleared. For L1, I'm going to put number 1. So I'm going to put 833, 796, 781, 776, 758. And I'm also going to put stuff for L2, just because it's more convenient for me. 27.2, 36.8, 50.4, 71.6, and 194.7. I'm gonna just stop here, even though I do have number 3 and 4. So how do you find average? Well, your calculator is a really neat function that will do that for you. So go to Stat again, and then now this time go to Calc, and then do 1 var stats, which is the first option. And it will ask you for the list. So since we are looking for average for number 1, we're going to put L1 because that's where my L1 list went in. We skip the frequency list, we don't ever use it, and we're going to calculate. And this actually will give you more than enough information that you need. But the one that I want you to look at for average is actually the first one, X bar. We call this X bar. And this is the sample mean. So for number 1, our X bar was 788.8. So mean is 788.8. Okay. What if I want to find out mean of number 2? Well, you go back to Stat, go to Calc, 1 var stats, change your list to L2, so it's a second 2. Calculate. And then it shows me mean, which is 76.14. Okay? All right. Let's go back to the central tendency because there is a median and mode. All right. Median is the number that you get when you line up your values in order. So from the smallest to the biggest number. I know you might have a repeating number, but that's okay as long as you have all the repeating number at the same time. So it's like 1, 2, 3, 3, 3, 4, 5, 6, something like that. So once you have reorganized them in order, the middle number, So you have the same amount of number here, same amount of number from the left, and then the middle number is your median. So sometimes you might not have a median as a number. So a quick example would be, let's say I have 1, 2, 3, 4 as my data. So if I go 1, 1, 1, 1, well, the middle of this number is between 2 and 3. So if that happens, you take the average of the two middle numbers. So here, median would be 2.5 because it has to be averaged between 2 and 3, which is, so if you add them up, it's 5 divided by 2, it's 2.5. So when you have an even number of data, you will often have to find the average of two middle numbers. If you have an odd number, then there will be a number that is exact middle, so median. So when is the median used? Well, there is a value, something called like an outlier. So outliers are the extreme values. It can be extreme low values or extreme high values. So any extreme values that goes out of the norm is considered outlier. And often what outlier does is that it pulls the distribution. So we can assume our distribution to be in like a histogram. So a histogram, then it will draw a little shape like this. And if there is an outlier, then you will have a little point like farther out. So your distribution now is skewed. Skewed meaning that it's been pulled to either one side or the other. It's not symmetrical. So whenever this happens in your data set, you actually don't want to use mean. So remember the example that I gave you. What if a lot of you actually failed my quiz and a lot of you also did really well on the quiz and there's nobody in the middle? Then mean would calculate the middle to be here, but your median would still give you a number either here or here, okay? I mean, in this case, median isn't also a great solution. It should be mode, but we're gonna talk about mode a little bit later. So let's talk about how to find median without lining the numbers up, because your calculator can do that. So I want you to use a calculator. So this is L2 because since I didn't touch anything, it's still the same window. And do you see how there's an arrow? So what you do with this arrow, so you go down, you choose the down button, down, 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 and it gives you a new number. It gives you minimum, something called Q1, mid, and then Q3, and maximum. And as you might have guessed, the mid is short for median. So for this data, median is 50.4, which makes sense because this one actually was written in order. So 50.4 is a middle number. Let's actually do number 3, because number 3 is not written in order, so it's less intuitive. And if you were doing it by hand, you would have to rewrite this data so that you can actually figure out where the middle number is. But since we have a calculator, that's what we're going to rely on. All right, so go to Stat, Calc, 1var Stat. We're going to change it to L3. Calculate. This one, mean is 33.4. If you go down, and median is 23.5. Do you see how off they are? They're not close at all, right? So this means that there are some extreme values, probably higher extreme values, that pulls your distribution, so it's skewed to the right. So we're going to talk about skewness a little bit more in a bit. I cannot see how much time I have left, so we might actually just do the central tendency. So we know about mean and we know about median. And mode is the most frequently occurring data. So like in this example where I have the two little humps, my two mode is this one and this one, assuming that they're happening on the same, like about the same number. So let's say this happened 10 times and this happened 10 times. Then I have two modes. And so whenever you have multiple modes, so if you have two modes, then you call the distribution bimodal because bi stands for two. And if you have more than two, you can call it multimodal. What if you have only one mode, which is like this case, then you call it unimodal. So you can tell by the prefix that comes in front of the word mode, you can tell how many peaks you are going to have in your distribution. So mode is usually a very useless piece of information unless you have a multimodal situation. So if you have a bimodal, you should state the mode as a central tendency because this meant that you have two different groups. You had a low performing group and the high performing group. So this study should have been conducted in two separate times or else you can't really get the middle of the population because clearly you have two separate groups, right? So mode isn't usually used, especially if your distribution is unimodal and symmetric. If it's unimodal and symmetric, you use mean. If you have some extreme values, you use median. And if you go to a distribution that is not unimodal, you start using mode. Let me teach you how to draw a histogram. So don't worry about the standard deviation and things like that, because I want to focus on central tendency a little bit today. I cannot see how much time I have left. That's not good, because it might just cut me off. All right, this is L3, so I'm going to show you how to draw a histogram for number 3. So what you do is you go to second y equal. And then plot 1 is on, which is fine, so enter. But make sure only one of them is on. And then I'm going to choose a type that is the bars, okay? And then I'm going to choose the X list to be L3 because I said that's what I'm going to do. And then you enter. And then second mode to quit. And then what you're going to do is you're going to go to zoom and then you're going to press 9 because zoom 9 is zoom step. Okay, so this is a histogram of this data set. And you can see that your mode, the highest value happens earlier on. And histogram is a little bit different than dot plot because it actually has an interval of numbers, not individual values. So trace, then you can see this was from minimum of 11 to 24.5. So this bar contains a value of 11, 17, 21, 22. So that's why it has 5 values. And if you move to the next one, it shows the minimum and it shows the maximum. And again, there's only one. And then another one, 38 to 51.5, 51.5 to 65, and so on. When you draw your own, you don't have to draw it by the calculator because sometimes I don't know how they exactly calculate how big the interval should be. Sometimes it's better to draw it hand because it's more intuitive. But you can see that this distribution, if I draw it here, it looks like this, right? So there was a bit of peak in the very beginning and it kind of like it kind of like slows down. There's not as many. So this, when you draw a little imaginary line over your histogram, and if you have a tail to the right, we call that skew to the right. And if you have about the equal amount of tail, then we call it symmetric. And if we have a tail to the left side, we call it skew to the left. So these are most of the cases that you will see. And again, if you have a skewness, like this one, you would not use mean, you will use median. That is because mean gets affected by an extreme value. So for example, extreme example, let's say I have 10 students in my class and 9 of them got 0, but 1 of them got 100. Then my average will be a lot higher than what it should be, right? If 9 people were all I had, my average should be 0. But because of the 10th person who got 100, now it's 100 over. So the average increased by 10. But is that really an accurate picture of my class? No, not really. My middle should be my center should be 0 because that's the most of my students scoring 0, and that 100 is the outlier. That's the extreme value. So that's why we choose median over mean when we have an extreme values and skewness and things like that. And so how do you know if there is a skewness